the recording should go live. All right, all right. So, ladies and gentlemen, my name is Onyango, Alan Onyango, and I lecture at Kenyatta University in Kenya. Kenya is in East Africa, and I'm going to be taking you through this course. I have over 7 years experience and in networking. I have certifications in CCNA. Those are global certifications, industrial certifications, CCNA, Cyber Ops Associate, DevNet Associate, the PC hardware and software maintenance and troubleshooting, HCIA, which means Huawei certified associate. And of course CCNA means Cisco certified networking associate. I have certifications in CCNP, Cisco certified networking professional. Yeah. Of course, up to now, I have a master's in pure mathematics and currently working on my PhD. And I have, been doing this for long now. And I just thought that, I'm gonna be working on the CCNA course and the CCNP course and all the other courses. And I'm gonna, share my knowledge. And of course, I've been nominated by Cisco to do this, to provide this for, for current students and even future students. So this, I teach at Kenyatta University, I teach at JCAT as well. I teach at Site Savers International. I teach at so many other academies, okay? And so I'm gonna try as much as possible to make sure that you guys get to understand technology, especially with reference to computer networking. And so my teaching methods are a little bit different because I teach with storytelling. For those who are Christians, I try to emulate the greatest teacher we ever had. And he always taught with parables. For Muslims call him Isa and Christians call it Jesus Christ. And I use the method of parables to break down technological concepts into much simpler to understand concept. And my teaching has been embraced by so many people across the world. During the COVID-19 pandemic, I taught thousands and thousands of people throughout the world. And we are doing that as a CSR in collaboration with Cisco. And so Cisco, in recognition for the work that I've been doing, they have nominated my skills and my teaching methods to use it for a program that is soon coming. This program called Africa and the Middle East NetAcad, Africa and the Middle East NetAcad Olympics 2023. So this is a kind of a networking clinic where we are going to train people in computer networks, and we're going to demystify the hard concept that people find in computer networking. And we're going to put this in YouTube, guys. And so for the sake of what we're doing, and this is going to happen to help generations and generations to come, we ask you guys to support us. Just please subscribe and share and like and hit that notification bell so that every time we record every video, you guys are going to pick it up. You guys are going to be notified. So I'll train CCNA, I'll train Cyber Ops, I'll train DevNet Associate, I'll train network security, I'll train courses in Linux, I'll train courses in CCNP Enterprise and CCNP Encore. And I'm going to try as much as possible to use a common language, a language that can be easily understood by people, And for this networking course, this is called, this is Introduction to Networks, and this is the foundations of computer networking, guys. If you cannot go through the foundations, you will not have a problem, understanding the concepts that will come later on. And in a short while, I am going to, of course, take you through why this is called a foundation course. It's because it literally lays the foundation for you. So we'll go through the CCNA 1, which is Introduction to Networks. We'll go through CCNA 2, which is Routing, Switching, and Wireless Essentials. And we will go through CCNA 3, which is Enterprise Networking, Security, and Automation. And so to start us off, I actually want to, I want to be able to just take you through what this course basically entails. So a first time in this course, this course introduces the architecture, the structure, functions, components, and models of the internet and other computer networks. And so the principles, let me just zoom this in to be seen by you guys. All right, I think this is a bit clear now. So the principles and structure of IP addressing and the fundamentals of Ethernet concept, media and operations are going to be introduced to provide a foundation for this curriculum. And so by the end of this course, we expect you as students or trainees to be able to build a simple local area network, LAN, perform some basic configurations for both routers, switches, and end devices, and implement IP addressing schemes. And so the reason why this course covers the foundations of networking is that it explains the advances in modern network technologies, number one. And number two, it implements initial settings, including creation of passwords and, of course, the strategies for creating passwords, IP addressing, which is a powerful thing. IP means Internet Protocol. And so for a device to participate within the Internet, it must follow the protocols on the Internet, and it must be identified within the Internet, and IP address is that which is used to identify devices within the Internet. Default gateways, parameters on a network, switch, and even end devices. We're going to explain how network protocols enable devices to access the local and remote network resources, all right? And, we are talking about both data, voice, and video traffic within the network. We'll explain how the physical layer protocols, and talking about the physical layer protocols, we are actually talking about the two models, OSI, which is Open Systems Interconnection, the OSI model, and the TCP/IP models. So the TCP/IP was the one that was implemented. The OSI wasn't implemented, but you can't understand the TCP/IP, which has 4 layers, if you don't talk about the OSI, which has 7 layers. So we look at TCP/IP model through the eyes of the OSI layer. So the first layer is the physical layer, and we look at protocols there, services, and the network media, which is basically copper, fiber optic, and wireless across the network data networks. Then we're gonna calculate the numbers, number systems, decimal numbering systems, binary numbering systems, and hexadecimal numbering systems for this particular first module. And so numbering is a very important part of networking. Then we're gonna explain how media access control, how can devices control the access to the media within the data link layer, that is the second layer of the OSI, and support communications across the network. We'll explain how Ethernet operates in a switch network, and Ethernet is a very powerful technology. We'll explain how routers use network layer protocols and services to enable end-to-end connectivity. We'll explain how ARP and ND, ARP means Address Resolution Protocol, and ND enable communications in a local area network. We'll implement initial settings on a router and end devices through configurations, basically. And then one of the epicenter of networking is in what we call calculations of IPv4 subnetting schemes to efficiently segment your network. That is what we call subnetting math, and it's a very important part. And if you get to understand that subnetting bit within the mainstream curriculum, it's about 12 to 15 steps. But being a mathematician, as I had already mentioned to you guys, I have reduced those 12 to 15 steps to just about 3 steps, and you guys, you're gonna like it when we get to chapter 11 of this course, where we'll be able to learn those 3 steps out of research, and they are not in the main curriculum, that is. We'll explain, of course, IPv6 addressing schemes as well. And, IPv6 is the future of networking, because we only had 4.3 billion IPv4 addresses. The world has overgrown. We have more users, people buying mobile phones every day. People have overgrown, and some people have more than one device, 3, 4, 5 devices, which need IP addresses. So the 4.3 billion IPv4 addresses could not support the number of users we have today. And so we needed to come up with IPv6, which has 16 undecillion addresses. Undecillion is a number with 36 zeros, by the way. So we actually have 340 undecillion and beyond addresses that are there for IPv6, and those ones we can use for billions of years to come. Then look at various tools to test network connectivity, compare and operate transport layer protocols in supporting end-to-end communications. We'll explain the operations of the application layer, that is layer 7, in providing support to end-use applications. We're going to configure switches and routers with device hardening features for security, that is. And finally, we'll troubleshoot connectivity in a small area network. So again, like I had mentioned, all this content, we're going to post it where everyone can access them and you can watch them over and over again. And just to let you know this, our channel, the channel that we are going to put this on is called, let me just get it clearly here. Yeah, the channel where all this is called the Alan, the Network Professor. Alan, the Network Professor. And you get there, please subscribe to this channel, share, likes, and press that notification button. And, we are going to make sure that we give you, very important content so that you can be able to share with your friends and you can be able to impact, within this century, because evidently we are trying to mentor the next generation. We are trying to mentor the next generation of network administrators, okay? So on YouTube, Alan, the Network Professor is the name that we go by. The profile as a pink shirt there, and this color, I don't know what this color is. This is a color almost closer to red. This must be I don't know that color, whether it's red or it's pinkish color there, whatever it is, but you'll find that there the name is Alan, the Network Professor, and that's the name of the channel where all these content is gonna be. Now for this upcoming clinic that we are doing, it's called the Middle East and African Network Olympics. And so it's a free training for both CCNA and CCNP. And so the training, of course, begins in February 14th and ends in March 31st of 2023. This is for the first module for introduction to networks, okay? And so after March 31st, everyone needs to have finished that particular CCNA 1. And then we'll follow with CCNA 2, which is routing, switching, and wireless essentials. CCNA 3, enterprise networking, security automation. And then the CCNP thereafter. And you'll get vouchers to go and take your industrial certification. And so, this, of course, this short form with just 3 responses for first name, last name, and email address to enroll yourself. And I'll provide that link, of course, at the end of this video. We'll be able to provide the link down there. Now, let's go back to, yeah, I think that color was maroon, I remember. Let's go back to this particular module here. This is the CCNA 1, chapter 1, module 1, and it's called networking today. It's called networking today. And what we are going to cover here, we'll explain how networks affect our lives today, how host and network devices are used, explain network representations and how they are used in network topologies, compare the characteristics of common network types, explain how LANs and WANs interconnect to the internet, describe 4 basic requirements of a reliable network. We'll talk about what is called BYOD, bring your own device, online collaborations, video collaborations, cloud computing, so on and so forth. Then we identify basic security threats and solutions for networks. Then we explain employment opportunities in the networking field today. So let's get started here and check out how networks affect our lives today. Now, all of us know that air, water, food, and shelter are basic needs that we have, that we need in our lives. But everyone can attest to it that lately, communication has been another basic need. If you ask people, how long does it take before they look at their phone blinking? How long do they take before they check on that WhatsApp message? The emails, before they check the new video posted on YouTube, And so it is important that we recognize that communications has become such important as the other, types of basic needs that we have. And so this has created a world without boundaries. Think of an event happening in the US, for example, and we are in Africa, and before we know it, the incident is already streaming live in all the parts of the world, and everyone can see it as it is happening. This is not something that was possible, let's say 20 years ago, where internet was not very vibrant and information was harder to come by. And it has led us to what is called global communities. We now have people of we subscribe to the same ideal, and we consider ourselves as the same community. A very good example will be something like football. Football, we have members of the Arsenal, members of Chelsea or Manchester United or sort. I'm not a football person myself. I am a basketballer, and so no offense here for if I didn't mention your team. And so you're members of one of the teams I've talked about, but you've never met each other. But whenever there's a win or you guys win against another team, you're able to celebrate together and you interact on social media, and it becomes, and look at the other social media platforms, Instagram, we have TikTok here, we have YouTube, and so those are global communities found all over the world, never met or maybe might never even meet. And this has led to what is called the human network. Have you ever been to a restaurant and you're seated with people on the table, you're having a meal, but everyone is on their phone, and everyone, unfortunately or ironically, is talking or communicating to someone who is very far away, and they have very little to do with the people they are seated with on the table, even if they are friends. And so the human network has become very, very powerful. Now, let's talk about what is a network composed of, the components of a network. And so the first component of a network are the end devices, okay? And an end device basically is where a message originates or where it is received. Think of your mobile phone. You create text messages, you capture videos, and post them on your WhatsApp status or on Google, on YouTube or on Facebook. So you are creating the message. So that means the message is originating, and it will be received when someone posts, you receive it again on your own device, okay? And this includes things like laptops, tablets, mobile phones, printers. We receive messages on the printer in paper form, voice over IP phones, you can name it. And so they can originate a message or they can even receive a message. That is the first component of a network. The second component of a network are what you call the intermediary network devices. Intermediary network devices. And so an intermediary network device basically are devices that interconnect end devices, which means for you to pass a message from one end device to another end device, it must always pass through other devices in the middle there. And these devices they don't generate, but they can regenerate. They don't transmit, but they can retransmit it from one device to the next device. They maintain information about the pathways that exist within the network, and sometimes they notify other devices of any errors or communication failures. And these intermediary network devices include the LAN switches, multi-layered switches, which we will see soon enough. We have routers, we have firewalls, we have wireless routers, we have access points, so on and so forth. Then the third component of a network are the network media. And the network media is the channel or the path through which the messages travel from one source to one destination. For your information, we only have 3 types of network media, and these have been there since network usage ever started. And so the first one is called the copper media. Copper media, this is the only type of media that is made of wires or metallic wires, okay? And so copper is the first network media, and that's why we have the Ethernet cable or the crossover cable or the copper straight through, those different names there. Now, because the copper is in a wired form, it carries the messages. And you know what messages are those, guys? The 3 types of messages in the internet are voice, video, and data. So they carry messages in form of electrical signals or electrical impulses because it is a wire, electrical impulses or signals. The second type of network media is called fiber optic cable. So the fiber optic, the word optic comes from light. It means the fiber optic is normally a thin glass fibers. Some of them are plastic, but glass is the common one. And so it's just a fiber or a small pipe. And the size of this glass fiber is, if you can touch one piece or one thread of your hair, all right, then that is how the fiber optic cable actually is, all right? So because it's just a glass pipe or a glass fiber, that light is transmitted in. So the messages, the internet messages, are transmitted in the fiber optic in form of light pulses or pulses of light, all right? Finally, we have the last type of network media called wireless. And from the word wireless, it's just wireless waves or wireless transmissions. You can't touch it, unlike the fiber optic and copper, you can't touch the wireless because these are just basically waves. And so they carry the messages in form of electromagnetic waves, So it's important, again, just to know that. Now, let's now talk about how do we represent most of the network and the network gadgets or the network devices, and also topologies. And so we're going to start with the network representations. So I can zoom this in. I'm going to zoom this in, and I'm going to check on the end devices, okay? And so under end devices, we have, of course, desktop computer is here. We have the voice over IP phone is here. We have a laptop. We have a wireless tablet. We have a printer. We have a digital TV, or we can call it a teleprocess endpoint there. And this is how we're going to represent them. Even as we will start talking about the most powerful tool we're going to use for learning called the packet tracer. we do that. Then, of course, the intermediary devices, wireless router is here, the LAN switch is here, the router, of course, is here, the firewall appliance is here, the multi-layered switch. For the network media, of course, we have the wireless waves there. The LAN or the copper cables are always represented by a black continuous line. Then the wide area network media is always represented by a red broken line or bent line. And the reason why we have this part here is because it quantifies a distance that we cannot estimate. It's a very long distance. For example, joining one city to another city. Now, each of these devices must have what is called a network interface card adapter for you to connect them with the cables. They must, of course, the devices also have, either a physical port, and we'll be using the word port and interface interchangeably to refer to the other, Now, let's look at two types of network topologies. And so we have the first network topology is called the physical topology. And by the way, a topology is just a network diagram. And so physical topology, I can just zoom it in and so that you guys can see it properly. So a physical topology is a network diagram. Excuse me. It's a network diagram which explains or tells us exactly where a device is located. For example, if I tell you that I want you to go to room 2158, 2158, that room there, go to rack number 2. How many rack? Oh, this device is rack 2 here. And go to shelf number 3. Okay, room 2158, rack number 2 and shelf number 3. What will you find there? You're gonna find there our file server. You're gonna file a file server. Okay, or if I tell you I need you to go to room 2159, where is that room 2159? Oh, it's down here. And you're gonna find there a printer. It is within the IT office, all right? Or I tell you, go to room 2142, 2124, 2124, go to rack number 1 on shelf 3. What are you gonna find there? You're gonna find there switch S5 is there. And so this is a physical topology. It tells us where the devices are physically located, and you can go and find that device there. Now, that is the difference between a physical topology and the logical topology, which is this one here. The logical topology, it doesn't tell us exactly where the device is located, but tell us how the devices are interconnected, in which network are they in, and which IP addresses, and on which interfaces are they connected to on the network. So it tells us the logical location of the devices, not the physical location, the logical connections of these devices. On which network are they? Like this is network 192.168.10.0. So that is logical and physical topologies. Logical and physical topologies. Let's now look at some common network types here. So we have different types of networks, and this is with reference to the sizes of these two networks. Now, we have the first one is called the small home network. This is basically a network that connects just a few computers, and these are the networks we use at home. Okay, and just a few computers connected to the internet. Then we have the SOHO, which is the small home office network, a little bit bigger than the small home, and it enables computers within a remote office, or basically a home, to connect with the corporate network, a network that can use to work at home. You can use it to work at home, doing your corporate work, but at home. Then we have what is called the medium to large networks. This is a network that is in many locations, and it has hundreds or even thousands of interconnected computers. And so banks use this network, universities, schools, so on and so forth. They use this particular network. Then the final one is the biggest network, and this is what is called the worldwide network. This is the network that interconnects all the hundreds of millions of computers found all over the world. And a very good example is the internet. The internet is an example of the World Wide Web. Let's talk about LANs and WANs. So LAN basically means local area network, and WAN is wide area network. Now, the difference between these two basically depends on the size of the area covered, the number of uses on the network, the number and types of services available, and the area of responsibility. And so, looking on the diagram on the right-hand side of my screen, you can be able to note the key here, whereby the yellow denotes the LAN and the purple denotes the wide area network. And so you can see a home office here. This is a LAN. This is a LAN, and the central is also a LAN. Now, for these three LANs to communicate together, we need the services of an ISP, Internet Service Provider, to interconnect these three networks to communicate together. And this is what we call a wide area network, because a wide area network interconnects different LANs to work together. All right. Now, internet. What is the meaning of the word internet? So internet is a short form of interconnection of networks. So this is the worldwide collection of all the LANs and the WANs throughout the world. And all LANs are connected to each other, of course, using WANs. And the WANs are now connected normally either copper wires or fiber optic or even wireless. But fiber optic has been the most common one lately, very, very common. Now, it is important to note that the internet as it is not owned by any specific individual or a group, okay? But we do have organizations, which we will talk about, which help to maintain the structure and the growth of the internet. And this includes organizations like IETF, the Internet Engineering Task Force, the ICANN, okay? The Internet Communications of Assigned Names and Numbers. And we're going to look at them soon enough, just to check on that. Now, what are some of the ways that we could use to connect to the internet? We have the DSL, the digital subscriber line, which is a connection to the internet through a telephone cable or telephone line. We have the cable mode. Cable is a very high bandwidth internet offered by television service providers. So the television service providers also provide us with internet and through what is called cable. So the word cable there is a technology. It doesn't mean any wire, Then we have the cellular. The cellular connectivity is the network connection to the network, this is the network that is used by our cell phones, And so the telcos, the telecommunications service providers, like, in East Africa, we have Safaricom, we have Airtel, we have Vodacom, so on and so forth in other countries. And so they have cell towers. And the word cell phone comes from this cellular technology, or the cell towers that are used to interconnect the cellular network. For remote places, like, in the ocean, a ship moving there, in the desert without any other connectivity, in space, where we have the planes and the rockets moving in the plane. We have satellite as a technology that can be used in any part of the world where no any other connection option can be available, okay? Of course, we have the dial-up telephone, which is an older method. We used to use modems. We used to hold modems. We could load some airtime into it and then put a SIM card and be able to dial and be able to connect to the internet. So these are just different ways that we're gonna be using to connect to the internet. Now, so next is, I want us to talk about something here. Very, very important. Converged network. Imagine 20 years ago, how did we used to, let's say, watch TV? 20 years ago, especially in Africa here, which is as a developed country or a group of developed countries, we used to have a black and white TV, and the most common one was a TV set called Great Wall. And for the Great Wall, you only needed an aerial and a coaxial cable, of course, running from the aerial to the TV set, and that was it. And at some point, you needed to rotate the aerial so that you could be able to connect yourself to the internet, okay? And basically, that was all, sorry, not to the internet, to connect yourself to view some TV content, either to watch a football match or watch some programs on TV. And so that's how, and TV was providing the video content. Guess how we used to make calls for voice traffic? We used to have telephone booths, you know, and there was the home booth that, you know, that had numbers. You could dial, then you rotate it like this. Some of you might not connect, but you know, it was so primitive, you know, and the telephone booth needed you to have a coin, and so you could insert a coin and then dial the numbers, and then you could you know, make a call to someone, and it wouldn't last even a minute, you know, something like 10 shillings or 20 or something like that. Oh, the most common one, the coin in Africa then, in Kenya then, was 5 shillings, Kenyan shillings then. Now, the telephone booth had no relations, the infrastructure for that telephone booth, it had no relation with the TV, the Great Wall TV that used an aerial. And those were very different infrastructures carrying different types of traffic. The telephone booth will carry the voice traffic, and then the black and white TV or the Great Wall TV will only carry video traffic. And then the data traffic, we had some form of internet connectivity. It was not very common. Most of it were in universities for research and government, some of the government offices, and they could use that to, you know, to do some browsing. But then I think there was no YouTube. We didn't have Facebook. We didn't have Twitter then. We didn't have TikTok. In fact, if you told people something about TikTok then, they will just be laughing at you because they never imagined such a thing would happen. And so, you know, you realize that the 3 types of infrastructure, one infrastructure carrying voice, another one carrying video, another one carrying data, very separated. Now, what is happening today, guys? Today, we have all this being carried by one infrastructure. Let's take your phone, for example. You could be browsing on your phone. You're still making a call, or you're listening to a call on WebEx or Microsoft Teams or Google or Zoom, and you are still watching some video on YouTube, you know. So the kind of infrastructure which can now carry both voice, video, and data, unlike previously, is what we call a converged network. This is going to come in your exam. A converged network can carry both voice, video, and data traffic and deliver it on the same network infrastructure, and we call this a converged network. Now, it is important at this point that you need to watch a video, which I can show you here. Let me just zip this. this and take you through. This is a very powerful tool that you guys are gonna need to know how to install Packet Tracer. And so let me just zoom out this to there. And so let me just launch one page here so that I can show you. You need to know how to install Packet Tracer because it is important, you know. And so if you once you log into your NetAcad account, you go to page 1.0.3. 1.0.3 is a video that takes you through the process of downloading and installing Packet Tracer. And that video is there. And there's another video on 1.0.4 on how getting started in Cisco Packet Tracer. And on page 1.0.5 is a logical and physical mode exploration of your Packet Tracer, ladies and gentlemen. So every time you want to do that, you just need to click the lower button that has an arrow there. You click that and it will be able to, you know, do that. Now, just to not to assume things here, once you log into your account on the landing page, go up there, go to resources, then click on Packet Tracer resources, click on Packet Tracer resources, and I must have been logged out. So I'm gonna need to log in again, and here I am. So go to resources, then click on Packet Tracer resources, and on Packet Tracer resources, oh, not that. Please, not that. It's download Packet Tracer down here. Download Packet Tracer. Click on download Packet Tracer. Then you scroll down to download, and you find where the latest version of Packet Tracer is. And the latest version is version 8.2.0 at the time of recording of this video. 8.2.0. Most computers nowadays, if you're using Windows 10, 8, Windows 11, you're gonna go for 6.64 bit download. So you're gonna click on that 64-bit download. If you're using Ubuntu or Linux, any Linux distribution, you click on the 64-bit. And if you're using the Mac operating system, you go for the 64-bit as well. All right. So that is where you get, and you need to have logged into your account to be able to do that. How do Packet Tracer look like? It's gonna just log and you're gonna it's gonna load in a few minutes. Now, the first time as you install Packet Tracer, please, it's gonna require you to put a username and password, or an email and password. Please put the email and the password of your NetAcad account. Put the email and password of your NetAcad account, and you know, and that's how you'll be able to launch Packet Tracer. So this is Packet Tracer. This is a new Packet Tracer without anything. Most of those that will come to your account will always come with a preloaded topology here with instructions on what to do, as we shall be learning. So you can do so many things with Packet Tracer. You can drag some routers. Click, for example, on the bottom left corner here, we have, you know, routers there, switches. We have end devices here. So every time you click on a router here, the different routers here will come here. Okay. Every time I click on end devices, the different end devices will also come here, from PC to laptop to server to, you know, printer, voice over IP phone, TV, tablet, smartphone, access points, on also all those end devices here. IoT stuff to do with IoT, stuff to do with stuff to do with wireless devices are there, stuff to do with multi-user connections, so on and so forth. So I can just click on a PC here, plug it there, And I can zoom this in so that you guys can see it really well. That's my PC. Oh, my laptop is there. My servers are there. My voice over IP phones are there. My TV is there. My tablet is here. You can see more here. And the wired end devices, so on and so forth. For my routers and switches, here my router, just click on it and click here. Those are my different routers there, 4331, 4321, 2911, so on and so forth. My switches are here. This is my layer 2 switches there. Layer 3 switches there. Different versions of the switches are actually here. I can look at my wireless gadgets. From the wireless router is here. You know, different wireless devices. The Meraki switch is there. The cellular booster obviously is there. And you can see the booster is already having a connection with some of the devices that we see here. The mobile phone is already connecting wirelessly to the booster and also the wireless router. Of course, my home gateway router is there. My access point is right there. So Packet Tracer, a very good device for, you know, modeling. Of course, my firewalls are here. My cloud infrastructure, of course, are also here. And, you know, so much to do here. For stuff to do with, for example, IoT, I will have devices like the blower is there, IoT blower. We have the IoT battery is here. We have the IoT wind detector is there, and we have a wind turbine. It's also there. Different, you know, devices there, and you can see some of these devices are already connecting wirelessly, you know, with gadgets here. So this is a very good, powerful tool for learning, you know. So that is Packet Tracer for us. I'm going to introduce you that, but follow those steps to install your Packet Tracer and make sure that your Packet Tracer is working as well. Now, let's now talk about why do we call a network a reliable network? A reliable network must meet the following 4 characteristics. Number 1, the network must be fault tolerant. The network must be scalable. It must have a good quality of service, and it must be secure. Okay? And so I'm gonna talk about each and every one of them so that we can be able to understand. So when a network is fault tolerant, what do you mean by that? So a network that can impact the can limit the impact of failure. What do I mean? This is a network that can be affected negatively one way. Let's say one device can go down, but that does not make the network to stop operating. Okay. And so how do we ensure a good tolerant network? A tolerant network must have what is called redundancy. What do I mean by redundancy? A redundant network is a network that has multiple links or multiple devices in the network doing the same thing. For example, let's say this router, which is connected to the internet, goes down, and someone needs to make a call or send an email from this PC. So traffic from this PC, if it cannot go through the switch to this router, and the router up there is blocked, it will still be able to go through this router and still go to the internet. Okay, this is a redundant network. We have multiple links and devices that are doing the same thing. Okay, and this helps to prevent what is called a single point of failure. What's a single point of failure? A single point of failure is like you have your house and you have a key to your house and you only have one key, such that if you ever lose that key, then you are doomed. You're gonna have to spend the night outside, because you can't get in, or you have to break the house. Now, to prevent single point of failure, please have more than one key and give your neighbor another key, so that if yours gets lost, you can still get another key and you can still access your house. All right. The second feature is scalability. A network that is scalable is a network that can expand quickly and support new users and applications without doing what? Without impacting or affecting the performance of the existing users. What do I mean, guys? You have your organization, and it is time that your organization has 5 departments, and you want to introduce the 6th department, a new department. And so what you want is this. You want to introduce the new department, connect it to your network, but you don't want the other 5 departments to complain. But since this new department was introduced, the network has become very slow. That is not a scalable network. The network must expand without impacting the services to the existing users. That is a scalable network. Quality of service. Quality of service is the process of giving priority to some traffic on the network and not others. And the one we are giving priority are urgent traffic. A good example, an ambulance. An ambulance, when you hear the siren of an ambulance sounding, it's either it is carrying a patient to the hospital, or it is going to pick a patient to take to the hospital. And you realize wherever the ambulance is sounding the siren, the other motorist will always give way. Okay? The other motorists always give way. They give priority to the ambulance. All right? Because the ambulance is carrying some urgent need, either to deliver or to go and pick up a patient. The same way, urgent traffic like live video or live streaming video and voice traffic, those ones are urgent traffic. And a good network will always configure quality of service in their routers and switches. And that makes the live video and voice to be able to be transmitted on the network without any interference. All right, that is quality of service. Who doesn't know about security? A reliable network must be secure. And security is in terms of the infrastructure security, the physical or the perimeter security, and the device security using passwords. And finally is information security. You must protect your information. You must protect your data. And the 3 goals of network security is called CIA. Confidentiality, which means only intended and authorized individuals should be able to access or to read information. Integrity, which means that as information is being transmitted from one source to a destination, we don't want anyone to modify any data or to alter data. And then availability is the assurance that of the availability of the network to authorized users. That is confidentiality, integrity, and availability. That is CIA. Ladies and gentlemen, we have new trends that have lately come out of the network. New trends that have lately come on the network. Now, the first one is called bring your own device. Bring your own device. The second one is online collaboration. Video communication is the next one. And cloud computing. Cloud computing. Now, so let's start with bring your own device, BYOD. BYOD is the process of allowing users in an organization at the workplace
to use their own devices at the workplace, and this gives them more opportunities and great flexibility. It could be their laptop, their tablets, notebooks, smartphones. They use their own devices because they get some kind of comfort and flexibility when they use their own devices. Then we have online collaboration. This can be using the WebEx Teams or Zoom or Microsoft Teams, so on and so forth. And we use this to collaborate and to work on a particular project or to have meetings. And you can share messages in it. You can post images and even videos and links. That is online collaboration. Of course, we have video communication, video calls. We do video calls on WhatsApp, video calls even on WebEx, video calls on so many other platforms, as we all know. Cloud computing, basically, cloud computing allows us to store our files or even to back up our data within servers that are found over the internet. Okay, and you can access this data stored there at any time and anywhere. Okay, and cloud computing has been made possible with what is called data centers. And data centers are very expensive to manage, and not all organizations, companies like Google, Facebook, they have their own data centers. And data centers are very expensive normally to maintain. Different types of cloud computing or clouds. We have public clouds. This is a cloud that is available to the general public, and it can be free or sometimes on pay-per-use. Anyone can use them. Private clouds, cloud that is intended for specific organizations, like the government, can have their own clouds where they store their own resources. Of course, we have hybrid clouds. This is made up of two. Yeah, this is a cloud that is made of two or more clouds, can be, public and private, so on and so forth. Then custom clouds, this is a cloud that is built to meet the needs of a specific industry. It can be the media or even healthcare, but it's tailored for a specific industry, We have some technology trends like the smart home, where we have smart appliances that are all interconnected to work together at home with our mobile phones. We have smart roofs, smart ceiling, smart windows, smart cars, smart everything, smart ovens. Okay, and this is being developed within all the rooms, smart beds and all that. Of course, we have what is called power line networking. These are new trends that are coming up. For power line networking, this is whereby you can use the standard power line cables to also carry internet messages or internet traffic. So use the power line cables to connect to the LAN. Wherever there is an electric cable, you can actually send data through the same cables. The power line networking company in Kenya for the government, Kenya Power Company, has been implementing this for some time in some places where there's no internet, no any other form of internet connectivity. Finally, we want to talk about network security. And security is not a small thing, guys. And we will cover more security. There's a chapter in, I think, second and third module, and even in this module. Of course, I'm going to show you all the chapters that we're going to be learning for this particular module. So that you can get ready, of course, for what's coming. So we have a great deal of security threats. Some of them are generated from the inside part of the organizations, and some of them from outside part of the organization. And network security is something that should worry every individual, every organization, and every CEO, because you never know what's going to happen. And someone says that as an organization is as secure as the weakest link that they have in the organization. Now, some of the external threats include viruses, worms, and Trojan horses, spyware and adware. We have zero-day attacks. Of course, a time will come when we'll discuss each of them. We have threat actors. These are the hackers. We have denial of service attacks. Someone is carrying their hand here. We have data interception and theft as attacks. And we have identity theft, where someone steals your identity. Those are some of the external threats. For internal threats, we have a stolen gadget or a lost gadget. We have accidental misuse of employees, and we have malicious employees. You know, these are disgruntled employees who either they feel they're being paid less by the organization and they can bring havoc within the organization. Those are threats that you can have within the organization. As part of solutions, again, we are almost done, guys. Here, in a few, we'll be, done with this class. As part of a security solution, we have antiviruses and anti-sparewares, which can be installed on end devices. And our devices also come with what is called a host-based firewall, which provides some level of security within the organization or for the end device. But we also have standard security dedicated devices, including dedicated firewall, access control list, which we will talk about. We'll configure our routers to work like firewalls using access control list. We have intrusion prevention systems, and we have the VPNs, virtual private network. So we will talk about some of this infrastructure soon enough. Finally, guys, this is a CCNA course, the Cisco Certified Networking Associate course. At the end of this course, you're gonna get a voucher to use to go and take your industrial certification exam. When you do that exam, of course, you'll get certificates. After this course, this is Introduction to Networks, you're gonna get a certificate. The second one is Routing, Switching, and Wireless Essentials. We call it CCNA 2. You get a certificate. You'll also get their digital badges and recommendation letters, which are written and assigned by the Cisco CEO, the global CEO of Cisco. And of course, with a certificate. Now, at the end of the third module, which is Enterprise Networking, Security, and Automation, you're gonna qualify to go and now sit for the industrial exam. And when you sit for the industrial exam, I think 1% of my students only are the ones that don't take the industrial exam. And I don't know it's because of what, but almost all my students go and take the industrial exam and they pass it, And so we do have other courses apart from CCNA. We have CCNP, which we will also be learning later on after the third module. And the highest, of course, CCNP means Cisco Certified Networking Professional. We have CCIE, which is a Cisco Certified Internet Expert. This is the highest level of certification you can ever do. I just did my CCNP the other day, and I'll be starting my CCIE soon enough to be able, to be certified on it again. Of course, Cisco has a new girl in town called the DevNet Associate. This is a course for network guys and programming guys. If you bring both the two of them together, we call them the DevNet Associate. So you are a developer and you can still be able to write script to be able to automate networking processes. And so this is CCNA. This is the latest version of CCNA, version 7.02. And it's a very interesting read. So this is the associate level. From the associate, we have the specialist and we have the professional level. You are also free to join for your networking jobs. You can join what is called the Talent Bridge Engine so that Cisco can always connect you with employers. Now, before I retire this recording or this video, I want to show you what are some of the things that we'll be studying in this course. it is important for you guys to learn that. So first and foremost, today we've talked about networking today. The second chapter will be basic switch and end device configuration. This is a practical one, and we're gonna configure the switch, and we learn a couple of commands for managing the switch and also for end devices. Then look at the protocols and models in the second module, protocols and models, where we'll talk about the TCP/IP model and the OSI model. The fourth one, we're gonna talk the physical layer. This is the first layer of the OSI, and let me just zoom them in here. Okay, sorry. Sorry, let me just zoom this in. All right, I need to do it this way. All right, exactly. Yeah. So the second topic is this is a very interesting one. We'll introduce you to the command line and configure it. Protocols and models is the second one. TCP/IP and the OSI models. Physical layer, here we talk about the network media, copper, fiber optic, and wireless and their properties. Number systems, we calculate conversions from decimal numbering systems to binary numbering system to hexadecimal numbering system. Very interesting, guy. That's where the networking math begins. Data link layer, we talk about the switch here and the MAC address, and we extend the study of the MAC address on the Ethernet switching, where we also talk about the switch, the structure of the switch, the MAC address table of the switch, and how is it that every device in the world has a unique MAC address. Then we go to chapter 8, which is the network layer. We talk about the IPv4 and IPv6 addresses here. We talk about their structure, and we talk about the router and the routing table and how it does it work. Chapter 9, we talk about address resolution, ARP, where we talk about the address resolution protocol, and the NDP, the neighbor discovery protocol. This is a very important protocol that we're going to learn. Chapter 10, we go to basic router configuration, where we now learn the commands of the command line for routers. Chapter 11 is a powerful one. This is the climax of the CCNA course, where we talk about the IP addressing. How do you subnet them? What are the types of IPv4 addresses? What are they used for? What are the categories? Why are we moving from IPv4 to IPv6? We're going to talk about those reasons. Then we talk about IPv6. This is the new girl in town. This is the future of internet, guys, and the future of networking. IPv4 had 32 bits. IPv6 has 128 bits. Guys, I'm going to use a very short method, very simple. This is the topic that most of my students, because I've taught thousands and thousands of students, this is the topic they find the hardest, but in my class, they find it the simplest. So welcome to my class once more. I'm going to teach it, and I'll also put the recording, on YouTube for the next generations, even after I'll not be around, so that they could be able to learn. Then talk about IPv6. We talk about ICMP, the Internet Control Message Protocol. These are the messaging protocols that we do have, ping and trace route. Then we're going to talk about transport layer. This is the fourth layer of the OSI models, where we talk about TCP and UDP protocols. Then we're going to talk about the application layer here. This is where we talk about all the applications from DNS to DHCP to FTP to TFTP, so on and so forth. We're going to have a chapter here for security, the network security fundamentals, where we'll explain all those terms that I just talked about. Finally, you're going to build a small network here. And for this chapter, you're going to have a challenge, what is called the skills integration challenge. You're going to get a packet trace activity, where you're going to implement all the skills we've learned in the whole of chapter 1. So this chapter has the CCNA 1, or the Introduction to Networks course, has 17 chapters, and they will go reducing. The second one will have fewer, and the third one will even have fewest. So, ladies and gentlemen, this is the end of this module. And again, I repeat, please go to this course. Below it there, you're gonna find a link where you can be able to enroll for the project that we are soon having here. The African Middle East NetCard Olympic 2023. It's a clinic where we going to offer a CCNA 1, 2, 3, and CCNP for free. And please subscribe, like, and share, and press that bell so that every time we post a new video, you're gonna get a notifications. Just to support us and just to make sure that you get this information. We are going to give you this material is like no other, never been posted on YouTube before. Most trainers have not always done something like this. So I have been approved. This is content has been approved by Cisco, and I have been approved by Cisco because I'm a Cisco trainer. I train instructors. I train students, in a variety of subjects. And currently, I lecture at a university in Kenya called Kenyatta University. And, I'll be able to do this. Kenyatta University, in collaboration with Cisco, are the ones that have made this to be possible so that we can be able to share our cream de la cream trainer experience or instructor experience with you guys so that you can get this knowledge. Others, thank you very much for this class, and I'll see you. Please, you'll find other videos for chapter 2 all the way to chapter 17. We'll all post them in the channel, Alan, the network professor. Otherwise, thank you very much, and see you in the next videos. God bless and Allahu Akbar. All right. So I'm gonna end this recording now, and I'll see you later on, guys.